Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're diving into a new season called Advanced Topics. We're joined by our resident Java expert, Victor. Hey Victor, ready to explore some cutting-edge concurrency concepts?
Absolutely, Sheila. I'm excited to delve into these advanced topics with our listeners. It's going to be a thrilling journey through some of Java's most powerful features.
Great! Today we're kicking off our first chapter on the ForkJoin framework, and we'll be focusing on the ForkJoinPool. But before we dive in, let's start with a quick quiz for our listeners. Here's the question. What's the primary advantage of using a ForkJoinPool over a traditional thread pool executor when dealing with recursive algorithms?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of why the ForkJoin framework was developed. Listeners, think about how recursive algorithms work and what kind of workload distribution might be most efficient for them. Don't worry if you're not sure. We'll break it down throughout the episode.
Excellent setup, Victor. Now, before we get into the details of ForkJoinPool, could you give our listeners a quick refresher on what we mean by concurrent programming?
Certainly. Concurrent programming is about writing code that can perform multiple tasks at the same time. In Java, this often involves using multiple threads to execute different parts of a program simultaneously. It's crucial for improving performance, especially on multi-core processors.
Thanks for that explanation. So, Victor, what exactly is the ForkJoin framework, and how does the ForkJoinPool fit into it?
Great question. The ForkJoin framework is a powerful tool for parallel processing in Java. It's designed to make it easier to break down large tasks into smaller ones that can be processed concurrently. The ForkJoinPool is at the heart of this framework. It's a special type of executor service that's optimized for a specific kind of problem, recursive decomposition.
Recursive decomposition? That sounds complex. Could you break that down for us?
Of course, imagine you're a chef trying to make a huge salad. Instead of doing it all yourself, you divide the task among your team. Each team member takes a portion of the ingredients, chops them up, and then combines their work at the end. That's essentially what recursive decomposition is, breaking a big task into smaller, similar tasks that can be done independently and then combined.
That's a helpful analogy, Victor. So how does the ForkJoinPool implement this concept?
The ForkJoinPool uses what's called a work-stealing algorithm. Going back to our chef analogy, imagine if one chef finishes their portion of the salad early. Instead of standing around, they steal work from other chefs who are still busy. This keeps all the chefs, or in our case threads, busy and ensures efficient use of resources.
That's fascinating. It sounds like it could be much more efficient than a traditional thread pool. Are there any real-world implementations of ForkJoinPool that our listeners might be familiar with?
Absolutely. One of the most common uses of ForkJoinPool is in Java's arrays.parallelSort method. When you call this method to sort a large array, it uses the ForkJoinPool behind the scenes to divide the sorting task and process it in parallel.
Wow, I had no idea. So how does a developer actually use ForkJoinPool in their code?
Great question. To use ForkJoinPool, you typically create tasks that extend either recursive task or recursive action. These are special classes designed to work with ForkJoinPool. Recursive task is used when your computation needs to return a result, while recursive action is used for computations that don't return anything.
I see. And I assume these tasks are where we implement the actual division of work.
Exactly. In these tasks, you implement a compute method where you define the logic for splitting the task and processing it. The ForkJoinPool then manages the execution of these tasks, including the work stealing we talked about earlier.
This is all really interesting, Victor. But I'm curious, are there any pitfalls or common misunderstandings developers should be aware of when using ForkJoinPool?
Great point, Sheila. One common mistake is using ForkJoinPool for tasks that don't involve enough computation to justify the overhead of task splitting. It's most effective for computationally intensive tasks that can be broken down into smaller, independent subtasks.
That makes sense. Is there a rule of thumb for when to use ForkJoinPool versus a regular executor service?
Generally, ForkJoinPool shines when you have a large task that can be recursively divided into smaller tasks, especially when those subtasks might have varying completion times. For simpler, non-recursive parallel tasks, a regular executor service might be more appropriate.
Thank you, Victor. This has been incredibly informative. Before we wrap up, let's reveal the answer to our quiz question. The primary advantage of using a fork join pool over a traditional thread pool executor for recursive algorithms is its work-stealing algorithm, which allows for more efficient load balancing, especially for tasks with unpredictable processing times.
Exactly right, Sheila. The work-stealing algorithm is key to fork join pool's efficiency with recursive divide-and-conquer style problems.
To summarize, we've learned that ForkJoinPool is a specialized tool in Java's concurrency toolkit, designed for efficient parallel processing of recursive tasks. It uses a work-stealing algorithm to balance load across threads, making it ideal for problems that can be broken down into smaller, similar subtasks.
That's a great summary, Sheila. And remember, while ForkJoinPool is powerful, it's not a one-size-fits-all solution. Always consider the nature of your task when choosing your concurrency tools.
Absolutely, Victor. In our next episode, we'll be diving into recursive task and recursive action, which will give us a more hands-on look at how to use ForkJoinPool. Until then, listeners, keep exploring the fascinating world of Java concurrency. Don't forget to subscribe to our podcast and leave us a rating if you're enjoying the content. See you next time.